Okay, in this video I wanted to look at some of the rest of these selected trig formulas and where they're coming from. We had already looked at a proof of the identity that is one of our sum and difference formulas. Okay, and the sum and difference formulas are really all about, section 7.5. And a lot of algebra on those identities would get you a lot of the other identities that are on this sheet here. Okay, so this sheet looks kind of overwhelming, but it's really just a bunch of algebra on one identity that kind of plays a role into all this other stuff. We're going to look at we're going to start here with the double angle formulas. The double angle formulas are in section 7.6, and here's the ones that you would see in the book. Okay, now the double angle formulas for sine of 2 theta and cosine 2 theta, these would be ones that you want to know when you get into Calc 2. You'll do lots of things with the double angle formulas in Calc 2. At the moment, you don't need to have those memorized or anything, but you'll be using them a lot in Calc 2, like I said, and at that point, they'll be worth knowing just because of, you'll be doing lots of things with them. So, we've looked at this identity, cosine alpha plus beta. We did that earlier. And here's what that would be equal to. Now, alpha and beta are just angles, right? So let's take alpha to be equal to beta. Cosine alpha plus beta, well, that would be the same as cosine alpha plus alpha if alpha and beta are equal. Okay, which would also be the same as cosine 2 alpha then, right? And where I've got beta, I've just replaced that with alpha there. And cosine alpha times cosine alpha, that'd be cosine squared alpha. Sine alpha times sine alpha, that'd be sine squared alpha. Okay, and that would be where this identity here comes from then. Okay, so I'm just starting with the sum and difference formula, and I'm letting alpha and beta be the same, and I get another formula then. Okay. Now, it may look like there's 3 different identities for cosine 2 theta. They're not. It's basically just using some algebra. Okay. Like if I use this identity that I just showed here, and I also use my Pythagorean identity, I know that sine squared alpha plus cosine squared alpha is 1. Then where I see the sine squared alpha term, that'd be the same as 1 minus cosine squared alpha using that Pythagorean identity, and I can get everything in terms of cosine. Cosine squared alpha plus cosine squared alpha, that'd be 2 cosine squared alpha, and then minus 1. Okay, so that would be where this identity comes from. To get this one over here, you're just going to use the other Pythagorean identity, but get everything in terms of sines. Okay. Go to the next page here. The power reducing formulas are here at the bottom of the page. Now these are also going to be really important formulas when you get into Calc 2. Okay, the power reducing formulas. You'll do lots and lots of things with those identities once you get into Calc 2. Again, at the moment, they're not worth memorizing, but you'll want to have those memorized when you get to the Calc 2 if you're doing the entire calc sequence. So let's see. We just looked at the identity for cosine of 2 alpha. Okay, that's equal to 2 cosine squared alpha minus 1. And so I've got that rewritten here. Now, if you solve this equation now for cosine squared alpha, add 1 and divide by 2, then we get our power reducing identity, which is this guy here. Of course, I could split this fraction into 2, and so cosine squared alpha would be the same as 1/2 plus 1/2 cosine 2 alpha in this case. Okay. The half angle formulas are also in section 7.6. Okay, and here's those identities. Maybe we can take a look at where one of them comes from. We can take a look at where cosine of alpha over 2 would come from. So I'm going to let theta be equal to 2 alpha. Theta is just an angle. Okay, alpha is an angle, right? So if I divide both sides by 2, then alpha would be equal to theta over 2. Now, I want to get a half angle in the mix here since I'm working with a half angle formula. Let me use this identity that I just established up here. Alpha is theta over 2. So where I see alpha, I'll just replace that with theta over 2. 2 times theta over 2, the 2's cancel. So that would give me cosine theta then over on this part. And to get rid of the power of 2, let's take the square root of both sides. Of course, when I take the square root of both sides, I need to remember the plus minus there on the right. And yeah, so that's where this identity would come from then. Okay. Now, I've got conditions. If you would use this identity if alpha over 2 is going to be a positive number. If alpha over 2 is in quadrant 1 or 4, it's going to be a negative if alpha over 2 is in quadrant 2 or 3. Now, that is not new information. We have already talked about all that stuff in Chapter 6. Remember that if you have an angle in quadrant 1 or quadrant 4, the adjacent side is going to be a positive. Cosine of an angle is adjacent over hypotenuse, right? The hypotenuse is going to be the radius of the circle. That's also always positive. If I have anything in quadrant 2 or quadrant 3, the adjacent side is a negative. And so I'll get a negative value then for cosine theta over 2. Okay. Again, that's not new information. It's just you're just using triangles, right? The basic information about triangles there. Section 7.7 is related to product to sum formulas and sum to product formulas. Okay, and so maybe we could just look at where a product to sum formula comes from. Maybe this first one in the group. Okay, for sine alpha, sine beta. How we would get this identity is we're going to take our sum and difference formulas, both of these in the middle, and then we are going to subtract them. Okay, so cosine alpha minus beta minus cosine alpha plus beta would be there on the left. Cosine alpha cosine beta minus cosine alpha cosine beta, those are gone. And then sine alpha sine beta plus sine alpha sine beta, that'd be 2 sine alpha sine beta. Divide by 2, and that's the other side of this identity. So again, you know, a lot of these are coming out from just simple algebra. Occasionally we might need like another identity, like a Pythagorean identity or something like that, okay? Maybe we could just look at, so there's some to product formulas. Maybe we could just look at like the first one in the group, sine alpha sine beta is 2 sine of alpha plus beta over 2 times cosine alpha minus beta over 2. All right, I'm going to start with the right side of this identity. I'm going to get over to the left side. Now, in order to show you where this identity is coming from, in this calculation, I'm going to be using a product to sum formula, okay, which is in the group right above. So I've got a product. I want to rewrite this as a sum. And okay, so in the product to sum group, sine of an angle times cosine of an angle, that's using the third identity there in the group. And I've got, I'll just keep the 2 in front. Now in that third identity, we want 1/2 the quantity sine of, where you add the 2 angles. Okay, so I'm adding these 2 angles together, and then plus sine of, where I'm subtracting the 2 angles. Okay, so I'm subtracting these 2 angles here to get that other term. And 2 times 1/2, those are gone, right? Left over in the brackets then. If I were to take these 2 fractions and split them into 4 fractions, I'll have alpha over 2 plus beta over 2 plus alpha over 2 minus beta over 2. Beta over 2 minus beta over 2, those are gone. Alpha over 2 plus alpha over 2, that'd be alpha. Okay, so I'll have sine alpha there at the beginning. And then over here, split these 2 fractions into 4 fractions. Alpha over 2 plus beta over 2 minus alpha over 2 plus, since you'll need to distribute, beta over 2, alpha over 2 minus alpha over 2, those are gone. Beta over 2 plus beta over 2 would be beta, so you're going to have a plus sine beta there. And yeah, that's where I had to get to, right? Sine alpha plus sine beta is the other side of this identity here, which I was trying to establish. Okay. So there's a lot of identities on this sheet here. Like I said, now these are all the identities that your book uses here to kind of wrap up the rest of chapter 7. And so and they do have proofs of where these are coming from, okay? And it's a good idea to see where these are coming from because, like I said, in calculus, you're going to be doing more with proofs, okay? It's just part of the class. And so we'll go ahead and stop the video here, and in the rest of the chapter, I'll show you some typical calculations that you would find in these sections here.